In this video, we'll be learning part 11.2 surface area of a sphere of chapter 11 surface areas and volumes of class 9 CBSE. We'll also be solving exercise 11.2 questions at the end of this video. Let's understand the meaning of a sphere before we find the surface area of a sphere. So a sphere is nothing but it's a 3D equivalent of a circle. For example, we have circles like these coins, right? So a sphere is a 3D version of this coin. You can imagine when you spin a circular disc along its diameter, it's going to form a circle, that is a sphere formation. Balls, planets and moons are some examples. You can imagine that when you take a circular disc, for example this coin, and spin it or rotate it along its axis along the diameter, then you form a sphere. So a sphere looks something like this. So it's a round ball. Or you can also imagine that planets, earth, moon, everything is a spherical form. In the figure here, we have represented the straight line as diameter, and the red lines show the revolving of the sphere, and the curved lines show the rotation of the circle in order to form this whole sphere. In order to understand the difference between a sphere and a solid sphere, you need to know that we refer to sphere as the surface of the ball here, or the surface part itself is the sphere. But however, a solid sphere includes what's inside the whole matter as well as the surface. So that's the difference between a sphere and a solid sphere. So you can say that a sphere is hollow, but a solid sphere is full. Now, surface area of a sphere can be written as 4 times the surface area of a circle, which is 4 into pi r square. Along with the concept of the sphere, we will also learn what a hemisphere is and what are the formulas for the hemisphere. So hemisphere is nothing but half of a sphere. Imagine you have sliced the sphere in half. So top half is a hemisphere and bottom half is also a hemisphere. Now curved surface area of a hemisphere can be written as half of curved surface area of a sphere, which is half of 4 pi r square. So 2 and 2 2s are 4. So this can be written as 2 pi r square. That is the curved surface area of a hemisphere. Now let's look at total surface area of a hemisphere. Unlike a whole sphere, you can notice that hemisphere also has a circular portion that forms its base. So we also need to include that in the total surface area. Upon doing that, I can write as CSA plus area of a circle, which is 2 pi r square plus pi r square, which is nothing but 3 pi r square, which gives me the total surface area of one hemisphere. Let us solve exercise 11.2 questions with our knowledge of a sphere and hemisphere and the formulas for surface area. Here we are asked to take pi equals to 22 by 7 unless mentioned otherwise. The first question is find the surface area of a sphere of radius 10.5 centimeters. So I know that the formula for surface area of a sphere is 4 pi r square. Substituting the value as 10.5 in the place of r gives me 4 into 22 by 7 into 10.5 whole square, which is 4 into 22 into 110.25 by 7, which comes to 9702 by 7, which is nothing but 1386 centimeter square, which is the surface area of the sphere of radius 10.5 centimeters. The second radius is given as 5.6 centimeters. Now A is 4 pi r square, and substituting 5.6 in the place of r, I get 4 into 22 into 31.36 by 7, which is nothing but 2759.68 by 7, which gives me the area as 394.24 centimeters square. Third one is 14 centimeters. So the radius is 14 centimeters and area is 4 pi r square. Substituting r as 14 gives me 4 into 22 by 7 into 14 into 14. So 7 ones are 14, 7 twos are 14. That leaves me with 4 into 22 into 2 into 14, which is nothing but 2464 centimeters square. The second question also asked us to find surface area of a sphere, but here instead of radius we are given diameter. So the first step should be convert this diameter into radius in order to plug it into our formula for the surface area of a sphere. So first one is 14 centimeters, and finding the radius gives me 14 by 2 as 7 centimeters, and substituting it in the place of r in 4 pi r square, I can write as 4 into 22 by 7 into 7 into 7. So I can cancel 1, 7 and 7, and I'm left with 4 into 22 into 7, which is 616 centimeters square. The second diameter is given as 21 centimeters, And now from this finding radius 21 by 2 will give me 10.5 centimeters. Substituting it in A equals to 4 pi r square, I can write as 4 by 22 by 7, 4 into 22 by 7 into 10.5 into 10.5, which I can write as 4 into 22 into 10.5 into 10.5 becomes 110.25 by 7, which is 9702 by 7, which is 1386 centimeter square. Third diameter is given as 3.5 meters. Now finding radius, I need to do 3.5 by 2, which will give me 1.75 meters. Now substituting it in the place of r, I can write as 4 into 22 by 7 into 1.75 into 1.75. Now 1.75 into 1.75 gives me 3.06. 4 into 22. The whole thing becomes 269.5 by 7, which becomes 38.5 meter square, which is the surface area of the sphere. In the third question, I am given the radius of 10 centimeters and the value of pi as 3.14 for a hemisphere, and I have to find the total surface area. Given radius is 10 centimeters, I know that total surface area of a hemisphere is 3 pi r square. I am given radius as 10 centimeters. I know that the formula for total surface area of a hemisphere is 3 pi r square. Substituting r value as 10, I get 3 into 3.14 into 10 into 10, which is 9.42 into 100, which is 942 centimeters square. Fourth question says the radius of a spherical balloon increases from 7 centimeters to 14 centimeters as air is pumped into it. Find the ratio of surface areas of the balloon in both these cases. So the initial radius was 7 centimeters, which has increased to 14 centimeters, and I have to find the ratio of the areas in both these cases. Firstly, I will note down R1 and R2 as the first and the second case and write the radius as 7 and 14 centimeters. Now, in order to find the ratio of surface areas, I can write A1 by A2 equals to 4 pi R1 square by 4 pi R2 square. Substituting the value of R1 as 7 and R2 as 14 gives me 7 1s, 7 2s, 7 1s and 7 2s, and 4 and 4 get cancelled. 22 by 7 and 22 by 7 also get cancelled. So I am left with 1 by 4. So I can write the ratio as A1 is to A2 equals to 1 is to 4. Fifth question says a hemispherical bowl made of brass has inner diameter 10.5 centimeters. Find the cost of tin plating on the inside at the rate of rupees 16 per 100 centimeter square. In order to find the cost of tin plating on the inside, I need to find the inner surface area. So inner diameter is 10.5 centimeters. Inner radius will be 10.5 by 2, which is 5.25 centimeters. Inner surface area will be 2 pi r square, because that's the formula for surface area of a hemisphere. Substituting r as 5.25, I can write this as 2 into 22 into 27.56 by 7, which is 1212.75 by 7, which is nothing but 173.25 centimeter square. This is the inner surface area. Now I have to find the cost for tin plating this inner surface area. I know that cost for 1 centimeter square is 16 by 100, which is 0.16. Now the cost for 173.25 centimeter square will be 0.16 into 173.25, which will be rupees 27.72. In the sixth question, we are asked to find the radius of a sphere whose surface area is 154 centimeter square. We are given the surface area, which is 4 pi r square equals to 154 centimeter square. From this, I can find the radius by sending 4 and pi to the other side, which becomes 154 by 4 pi, which is 154 by 4 into 22 by 7. 7 goes to the numerator, and I can write this as 7 into 154 by 4 into 22. Then r square value becomes 12.25. Now to find r, I have sent the square to the other side, which becomes square root 12.25. I can write this as 1225 by 100, which is nothing but 35 by 10. I can write this as square root 1225 by 100, so that I can find the square easily, and this becomes 35 by 10, which is nothing but 3.5 centimeters, which is the radius of a sphere whose surface area is 154 centimeter square. In the seventh question, we are given that the diameter of the moon is approximately 1/4 the diameter of the earth, and we need to find the ratio of the surface areas. Writing the information given in the question, I can write as 2rm, that is diameter is nothing but twice the radius, so I am writing in terms of radius here, is equal to 1 by 4th of what it is of the earth, that is 2re. Again I am writing the diameter of the earth as 2 times the radius. Here 2 and 2 gets cancelled, so I can say Rm equals to 1 by 4 Re. Now I can send the 4 to the other side and I can write Re as 4 Rm. Finding the ratio of the surface areas, I can write Am by Ae, that is area of the moon by area of the earth, equals to 4 pi Rm square by 4 pi Re square. Here I can substitute Re as 4 Rm. So writing that gives me 4 pi Rm square by 4 pi into 4 Rm whole square. Here I can write this as 4 pi gets cancelled and I can write it as Rm square by 16 Rm square. Rm also get cancelled and I get Am by Ae as 1 by 16. I can write Am is to Ae as 1 is to 16. Let's take a look at the question in exercise 11.2, which says a hemispherical bowl is made of steel of 0.25 centimeters thick. Inner radius of the bowl is 5 centimeters. Find the outer surface area of the bowl. Now, given inner radius is 5 centimeters, so thickness is 0.25 centimeters. You can imagine a hemispherical bowl that would look like this. So, if there was an inner radius, this radius is 5 centimeters. So, to find the outer radius, I would need to add this part as well, which is 5 plus 0.25, which is 5.25 centimeters. To find the outer surface area, I can use the outer radius in the formula 2 pi r square. Substituting it gives me 2 into 22 by 7 into 5.25 into 5.25, which is 1212.75 by 7, which is nothing but 173.25 centimeters square. The last question, question number 9, says a right circular cylinder just encloses a sphere of radius r as shown in the figure here. In the first part of 9th question, we need to find the surface area of the sphere. So we know that the formula for the surface area of a sphere with radius r is equal to 4 pi r square. So the answer for the first part is 4 pi r square. The second part says to find curved surface area of the cylinder. Here the formula for the surface area of the cylinder is 2 pi r h. However, we can write h as 2r because it is mentioned that the cylinder just encloses the sphere. So the sphere will be touching the top and the bottom part of the cylinder and the total diameter of the sphere will be the height of the cylinder. So I can write as 2r. Here substituting 2r in 2 pi rh, I can write it as 4 pi r square. The final part asks us to find the ratio of the area of the cylinder and the sphere, which is nothing but area of the sphere by area of cylinder, which is 4 pi r square by 4 pi r square, which is 1:1. With this, we have come to an end to part 11.2.